All right, let's look at the theorem 3, integration of Laplace transforms. All right, so if you take the Laplace transform of f of t over t, instead of multiplying by t, we're dividing by t this time, then this is going to be an integral from s to infinity, capital F of sigma with respect to sigma. The only reason why we're using sigma is that the s is already used here, so we cannot use the same letter. That's it. All right, so and equivalently, of course, you can just take the inverse Laplace transform both sides. We can then solve for f of t, which is t times inverse Laplace transform of the integral. All right, let's try to prove this initial one. All right, I'm going to actually start from the right-hand side again. So I'm going to start with the integral from s to infinity. All right, capital F of sigma with respect to sigma. Right? So let's rewrite it using the definition. So integral from s to infinity. That's already there. That looks like 6 here. Right? So let's just rewrite it. So that's going to be, this is s, right? All right, so this is a Laplace transform. So you have an integral from 0 to infinity. Right? And then you have a e to the negative, right? Instead of s, you have to use sigma t, f of t, dt, and then with respect to sigma, right? Then we're going to switch the order of integration, and we're going to have to, let's see, we're going to put integral from 0 to infinity, and then you have an integral from 0 to infinity. All right, so you have e to the negative sigma t, f of t. All right, so we're going to do a d sigma first, then we're going to do with respect to t later. All right, so this is an integration. So let's see. We have, so I'm going to leave outside integral for now. All right, and if you look at this f of t, this guy has nothing to do with sigma. We can actually put it outside of the integral. So we have integral, actually integral of e to the negative sigma t with respect to sigma. I'm going to go ahead and do it. So antiderivative is e to the negative sigma t over negative t, right? Then you're going from s to infinity. So s to infinity. And you have a f of t is outside. We have a dt. All right, so if you evaluate that, you're going to get this integral from 0 to infinity. Right? If you plug in 0 for sigma, so e to the negative sigma t, and this is just going to be a constant, so it's going to go to 0, right? E to the negative infinity. So it's 0 minus, plug in s, you have e to the negative st over negative t, right? Then this guy times f of t dt. But you can see that we can clean it up. 0 really doesn't do anything, and the negative sign, double negative, cancel out. So we can clean it up as integral from 0 to infinity. You have negative e to the negative st. Then you have f of t, and then over t dt. All right, by definition, this is just a Laplace transform of f of t over t. All right, so that proves the theorem number 3. All right, that's it. I hope that this was clear.